Example 15 stops giving you examples of mathematical problems and writing them in predicate form, and it starts talking about how do we manipulate predicate statements. This is not as simple as propositional statements. Now, if we don't have any of those quantifiers, right, for all or exists, then we can treat it just like any of our propositional statements, and theorem 1 applies really easily. But if we do have for all or exists, things get a little bit trickier. And that's why things like Fermat's last theorem took 350 years to prove. This stuff gets complicated. It's not as clear. And the question is, can we move our quantifiers through our statements the same way we move the negative using De Morgan's law or distribution or anything like that? And the answer is sometimes. And we're going to take a look at the, when we can and why we can and why we can't. And in any individual case, you'll have to make a justification for why you can or why you can't. So let's say we have the statement for all x that are members of set D, P of x is true and Q of x is true. And really we should put this inside parentheses. So is that the double implication with for all x that are members of set D, P of x is true, and for all x that are members of set D, Q of x is true. So in this case, yes, it is true. We can distribute it that way. Let's look at another one. Let's say there exists x as a member of D such that P of x is true and Q of x is true. So does that imply that there exists x that's a member of set D such that P of x is true and exists x that's a member of set D such that Q of x is true? And the answer is no. That is false. And it makes sense if you think about it. In our first statement, we're saying for all x, right? For all x, P of x is true and Q of x is true. So if you're saying, for all x, P of x is true, and for all x, Q of x is true, those are, we can understand intuitively how those are equivalent. But here we're just saying there exists an x in D such that if you put it into P and you put it into Q, it'll be true. When we separate those, we could be choosing different values of x, right? This x is not the same as that x. Those are two different variables in that second case. So those two are not equal, so there is no double implication. That's why that second statement is false. Let's move on to another one. For all x that are members of D, either P of x is true or Q of x is true. And if we distribute that in, for all x that are member of D, that are members of D, P of x is true, or for all x that are members of D, Q of x is true. So is that true? That is very much not true. And think about it for a second. The first one says that for all x in D, either P of x is true or Q of x is true. The second one says, and this is a very different statement, all x are true for P of x or all x are true for Q of x. So if it's all true for P of x, it doesn't matter if it's all true for Q of x, and vice versa. That's a very different statement than saying for all x in D, either the x is true for P or the x is true for Q. Okay, and our last statement here, there exists x as a member of D such that P of x or Q of x is true, implies the existence of x is a member of D, P of x, or the existence of x is a member of D, Q of x is true. So, are those two equivalent statements? This one's a little bit trickier, but yes, they are, right? I'm saying in the first one, there is an x inside D such that Px or Qx is true. In the second one, I'm saying there exists an x in D such that P of x is Q, or there exists an x in D such that Q of x is true. Those are equivalent statements because I just need to find an x that is true in one of those two for each of those individual propositional, they're all predicates, for each of those individual predicate statements. But the key thing is it's not so straightforward, is it? It's not as clear when you can move the quantifier through and when you can't. And because we start mixing in English words along with our symbols, you can't always just set up a rule that says yes you can or no you can't, or here's how you can. This gets more complicated. And that is our life for the rest of the semester. This gets more complicated. If you have any questions, ask them in the forum below, and we will be talking about this next week. All right? Good luck.